Hi Chemistry, I wanted to demo a couple of percent error problems for you, and we'll see how this works. It's my first time doing Screencastify with my DocuCam, so that's kind of exciting. Okay, so just remember the percent error formula is you're taking your experimental value minus your actual, like the correct value. Taking that, subtracting the difference there, and dividing it by the actual or correct value. And you're multiplying that by 100 to get that into a percentage, okay? So I wanted to demo a couple of these problems because for the later ones, there's some other additional things you have to do, okay? So number 6, the student was measuring the time it took for an experiment to take place. They found the time to be 40 seconds. So that's their value, that's our E. However, they had started timing a few seconds after the experiment had started, and the actual time, or the correct time, whatever letter you want to use, is 43 seconds. So what is the percent error? Okay, so I always like to make a little key. So the experimental value was 40. The actual or correct value was 43. And that difference, right, that change was 3 seconds. And these are in seconds. Okay? So you could actually skip the subtraction step if you wanted to, since you're doing it right there. But this is just 3 seconds divided by the actual time of 43 seconds. Excuse me. And you would get 3 divided by 43 equals, your first step is 0.07, because I'm rounding up, right? Remember we've talked about sig figs too. So there's 2 and then there's 1. We're still working on that though, right? And then you're going to multiply that by 100. So we get 7%. We didn't even need to do that on the calculator because you could just move the decimal, right? 7% error. Okay. Oops. All right, so that's that one. Let me hit pause and regroup here. All right, in number 7, there's another step that you're going to have to do. So I just wanted to point that out. I'm not going to demo that one. I think you could do it. But a lab group was calculating the speed of a radio car. They measured the distance traveled to be 6 meters and the time to be 3.5 seconds. Okay? So then they divided the distance by the time to find the speed. So this tells you what you need to do right here. Divided the distance by the time to find the speed. Okay, and then they give you the actual speed. So you have to do this step first. So divide distance, I'll show that to you, of 6 meters divided by time, 3.5 seconds. Okay, and then your units are going to be in meters over second, right? Okay, and then you can use this value to figure out the percent error. This is going to be your experimental value, and this is your actual value, your correct value, okay? Hopefully that gets you where you need to be for that problem. All right, back again. You don't even know I'm hitting pause, but I am. So in number 9, similar situation. So here we go. Some students were measuring the volume of a cube-shaped wooden block. They measured the length to be 5.08 the width to be 5.09, and the height to be 5.10 in centimeters. The actual volume of the block was 15.3 centimeters cubed. Okay? What's the percent error? Oy vey! What do you have to do? Remember geometry, math? To find the volume, which you're going to need to find the volume of what they measured, it's length times width times height, right? And then that will get you the volume, and your units are going to be centimeters cubed. Again, this is your actual volume right there, and this one's going to be your experimental volume. Okay, so hopefully that helps. All right, I decided to go back to number 8. So we're looking at density either tomorrow or later in the week, next week. I haven't decided what I want to do with you guys tomorrow yet. But here we go. In an experiment determining density, students were measuring mass and volume. They found the mass of their substance to be 8.12 grams and the volume to be 1.9 centimeters cubed. The actual density was 4.5 grams over centimeters cubed. So what's their percent error? Holy cow! So the formula, which you're going to learn when we cover it, formula for density equals mass divided by volume. Okay? So you have your mass of 8.12 grams, and you're going to divide it by the volume of 1.9 centimeters cubed, and that's going to get you in grams over centimeters cubed your experimental value, okay, right there. And this is your actual value. Okay, hopefully that helps. Number 10 is the same kind of thing where you have to do a couple of steps before you can calculate the percent error. So a student was measuring the ratio of a circle's circumference and diameter. They found the circumference to be 6.28 centimeters and the diameter to be 1.8 centimeters. The actual ratio, circumference divided by diameter, so circumference divided by diameter, was 3.14. So what's their percent error? All right. So again, you just have to do that. Divide that circumference by the diameter. So 6.28 centimeters divided by 1.8 centimeters. Okay, and that's going to get you your experimental value. All right. And I guess actually the centimeters cancel out, don't they? So you wouldn't have a unit there. And then your actual is right there, 3.14. Okay? So hopefully that helps. Number 9. This answer is going to be really large, and I think there's just an error in the question, so don't freak out about that. All right? Thank you, and I hope this was helpful.